Okay, so yesterday I gave you a question. So have it as example 1. Where we are looking at sketch P of X is equal to X power 3 plus X squared minus 5X minus 2. So the question had a piece where it was saying show that X minus 2 is a factor of Px. So whenever you are given to show that that X minus 2 is a factor of the polynomial, you get X minus 2, equate it to 0, and solve for X. Get the value, take it in P, and see what we are getting. This is 8 plus 4, that's 12, minus 10 minus 2, that's 12, giving us 0. So we are saying the remainder is 0, hence shown. That was to show that it's a factor of, that. But for you to use it to sketch, you get the same tool. Use synthetic division, collect the coefficients of the polynomial, drop the first number down, multiply, add, again multiply 2 by 3, 6, you add, you get 1, 2 by 1, you get 2, you add, you get 0. So you can now write the polynomial P of X as a product of X minus 2 multiplied by X squared plus 3X plus 1, like that. What this means is that for you to sketch, you need to get the x-intercepts. So I deliberately asked you to solve for this is equal to 0 because that's how you get the x-intercept. So you equate the whole thing to 0, telling us that x minus 2 is 0. Of course, for this one, we already know x is 2. Then get x squared plus 3x plus 1 is equal to 0. No factors, so you use the formula. So you use the formula, x is negative b plus or minus the root of b squared. So we have 9 minus 4 multiplied by 1, everything over 2 by 1, which is just 2. So the values of x we are getting are negative 3 plus root 5 over 2, or negative 3 minus root 5 over 2. So these three values of x are the x-intercepts. Then I also asked you to solve for P of 0, which helps you to find the y-intercept, which is negative 2, so that the y-intercept is 0, negative 2. So now we have all the intercepts, so we can sketch our polynomial. So it will be a nice polynomial sketch. with intercepts 2. So we have 2. And then we have -3 plus, look, root 5 is less than 3. So when you say -3 plus root 5, it will be a negative number. So we'll have to bring it here, plus root 5 over 2. Another negative number is -3 minus root 5 over 2. Then we go for the y-intercept to give us orientation. It is 0, -2. So 0, -2. So if you try 1, so deliberately let's try 1 and see what the function will give us. So P of 1 is 1 plus 1 minus 5 minus 2, giving us -5. We want to compare this number to the y-intercept, which is -2. So you've seen that this number is lower than -2, telling us that our graph will have its, so our graph will be of this nature, coming down, cut there freely, turn in this direction. So normally, you suspect that the turning point of the graph will be in the longer interval between the closest intercepts to the y-axis. So this is x, that is px. So that's how you sketch your polynomial. So what will happen is that when we do calculus, we'll find a way of knowing these turning points in calculus. For now, we don't know them, but then calculus will help us if we know what the turning points are. So this was example 1. So we'll have another example, so that in case you have some questions, the next example will answer some of your questions. Example 2, sketch P of x is equal to x power 3 minus 2x squared minus 7x plus 12. So whenever you have such a polynomial and the question just says sketch, you have so much work to do. The first thing is that you look for a 0 of the polynomial. Look for the value of x, that when you substitute whether it's x in the whole polynomial, you get a 0. So the guidance is that you look for the factors of the constant or the factors of the coefficient of the highest degree. Now the highest degree in this case is x power 3 with coefficient 1. So if you look at those factors of 1, which is 1 and -1, you get 1 minus 2 minus 7 plus 12. This fails to be 0. We try -1. We'll get -1 minus 2 plus 7 plus 12. This is by far not 0. We get 2. We have 8 minus 8 minus 14 plus 12, not 0. let's get -2. We have -h minus h plus 14 plus 12, not 0. There's so much work to do. Let's go to 3. We get 27 minus 9 by 2, that's 18, minus 21 plus 12. This guy looks like we are getting 39 if you add 27 plus 12, minus 39 if you add 21 and 18, giving us a 0. So we have found one number that gives us a 0. So we know that x, since the number is positive, we know that x minus 3 is a factor of p of x. So I want to use 3. So you put 3 there. In synthetic, you correct all the coefficients of the polynomial. So we have 1, we have -2, we have -7, +12. And then drop 1, 3 by 1, you get 3, get to add. We have 1, 3 by 1, we get 3, get to add. We have -4. 3 by -4, we get -12, get to add, we have 0. So the polynomial p of x is now written as the product of its factor x minus 3 and the quadratic this. So now the next thing is we solve for the x-intercepts by solving for p of x is equal to 0, telling us that x is equal to 3 and x squared plus x minus 4 is 0. So you cut these pieces to 0. Now if you look at this, it doesn't have normal factors. So again, we go for the formula. So we say x is -b, which is -1, plus or minus the root of 1 when you square it, minus 4ac. Now c is -4, so we'll get a positive 16 over 2, giving us the values of x, -1 minus root 17 over 2, or -1 plus root 17 over 2. Now root 17 is a positive number. I mean, when I say positive, root 17 minus 1 is still a positive number because positive root of 16 is 4. So root of 17 is 4 point something. 4 point something plus 1, I mean minus 1, is 3 point something. Okay, and you divide by 2, so it will be 1 point something. I mean that's a positive number. So let's get the y-intercept. Whether it's x, you take 0, you get a constant 12. So the y-intercept is 0, 12. So we should be able to sketch now. So this should be our sketch. So we have 3. We also have -1 plus, we also have -1 plus root 17 over 2. We also have -1 minus root 17 over 2. And then we have 12 as the intercept. So if we try 1, and -1, we just want to have an idea whether it will, what will happen near, around the y-axis. Does our graph go and have a turning point after the y-axis from the left or to the left of the y-axis? That's what we want to check when you're doing this. So let's see what P of 1 is. Of course, we are already getting P of 1 here. We didn't just get the final value. So if you try to get the final value, we'll have 12 minus 7, that is 5, minus 2, that is 3, plus 1, that is 4. So this one was giving us a 4. If we added all these, we are getting 4. What if we did the addition on -1? We are getting 12 plus 7, that is 19, minus 3, that is 16. 16 is bigger than 12. So meaning, on the left here, we're getting a number bigger than 12, so the graph goes beyond, as it is coming down to the y-axis. So our graph should be having this behavior, cutting through here, going that way. So this will be our graph. So what happens normally is that you first suspect the space that can take the intercept, the turning point, by looking at the bigger space between the closest intercepts to the y-axis. And then be serious when you're testing in the interval that you suspect that it will have the turning point. Based on the same example,
So I have a question. Is it always when you're testing for a number, for a turning point, is it always that it's supposed to be greater than the one in the y-axis?
is it always that you
Like
should get a number that is bigger than the number on the y-axis?
yes, for the turning point.
Not always. Sometimes you get all the numbers lower so that you make the number on the y your turning point.
Okay, thank you.
So, but don't need to worry, because soon we'll be looking at calculus that will come with ways of knowing the turning points, meaning that by the time you're writing an exam, when they ask you to sketch, they may demand for the turning points, meaning that the calculus will help you now know the actual turning point. So there will be no need of testing around the y-axis, because you would have known what your turning points are. So on the same question, if they say solve for P of X greater or equal to 0, what you do is, after you have sketched it like this, you pick the intervals for which the function is greater or equal to 0. So you pick intervals where it is on the positive y. So in this case, we would have said our solution set from the graph is starting from -1 minus root 17 over 2 all the way up to -1 plus root 17 over 2, close here, union, start at 3, going to infinity. So we'll just pick the intervals that are giving us the curve on the positive y. Positive y meaning above the x-axis. If the question was asking us to solve for p of x less than 0, the solution set becomes from negative infinity all the way up to negative 1 minus root 17 over 2 union negative 1 plus root 17 over 2 comma 3. So sometimes there are some questions that can be phrased in that manner. So you must be a bit careful not to worry. And remember that you guys, we have done inequalities, which means that even if you didn't have an idea of the sketch, you can just get your factorized form and apply the inequality concepts that we learned. So our next sketch, example 3, sketch f of x is equal to the modulus of, where is it? The modulus of x squared plus 3x minus 2. So the modulus of 3x, x squared plus 3x minus 2, indicating the least and greatest value. So what we do here is we first forget about the modulus, pick a curve x squared plus 3x minus 2. Now, computing the square is the best method sometimes, but not always. So sometimes you can just pick the important concept of computing the square. We know that x is equal to negative b over 2a gives us a line of symmetry, and our b here is 3 and our a is 2. So negative 3 over 2 is the line of symmetry. If you pick this number, take it in y, it will give us a turning point. So we have this number square plus 3 negative 3 over 2 minus 2, giving us 9 over 4 minus 9 over 2 minus 2. That is 4 down. 9 minus 18 minus 8, giving us negative 9 minus 8. That's negative 17 over 4. So our sketch is supposed to have a turning point at negative 17 over 4, but because it is in the modulus, it will have its turning point at 17 over 4. comma, -3 over 2. So the modulus will only affect the y values. So whatever y value you get, so let's go for the y-intercept. The y-intercept is when x is 0, so we'll get -2, meaning that the y-intercept, instead of it being -2, it will now be +2. So whatever you get in the y, the modulus will make it positive. And then we now solve for the x-intercept, where we just equate y is equal to 0, meaning x squared plus 3x minus 2 is equal to 0. Now it looks like only the formula here can help us. That is -3 plus or minus root of 9 plus 8 over 2, giving us -3 minus root 17 over 2, or -3 plus root 17 over 2. So root 17 is bigger than 4. So 4 point something minus 3 is a positive number. So we have -3 plus root 17 over 2. On the left, it will be -3 minus root 17 over 2. The graph is supposed to cross this coming down, but then it won't cross because of the fraction that is being done by the modulus. So our graph will come all this way, hit here, and then make a curve. Hello?
Yes, sir. Can you just repeat that statement where you said the graph won't cross that because I said something?
It does not cross the x-axis because whatever we are supposed to obtain on the x to be negative on the y-axis, the modulus has made them positive. Remember, we had the intercept -2, the modulus has made it positive. So we have no point on the negative y. Everything has been taken up by the modulus.
Okay, thank you, sir.
Okay. So our turning point will be there. So the graph will go 10 from there, come down. So it has become an issue here to sketch because of the nature of the graph. So let's see. Okay, I'll write this. Okay, so I've widened it too much. Okay. So I'll first sketch. I know this is and that is 17 over 2, not root. So that's 17 over 2. 17 over 4. Okay. So our sketch is coming. Our sketch is coming all the way from here. It will hit there. Go up. Come down. Go up again. Where this point here is -3 plus root 17 over 2, like that. So wherever it was supposed to, so this curve here was supposed to be down, but because of the modulus, it has been reflected to the positive part of y. That's the only reason why it has remained that side. So we do example 4. Before, here we are also asked to indicate the least and greatest value. So the least value as you can see here is f of x is equal to 0. So the graph can go as low as the x-axis where y is 0. And then the greatest value will be f of x is equal to positive infinity, because the lines keeps going up. But you will notice that in calculus we have what we call the relative greatest value. In this case, it would have been f of x is equal to 17 over 4, where the graph on the curve is turning. So we call that a relative greatest value, not the greatest. It's just relative because for some good numbers, it's the biggest in that interval. But for the whole function, the greatest value will be infinite. Okay. Example 4, sketch t of x is equal to negative modulus of negative x3 plus x squared plus 5x minus 2. This is a polynomial in the modulus. First thing again, we forget about the modulus and get the inside curve. Look for a 0. So let's try, if we try negative 1, we can see that it won't give us a 0. So when we're doing at negative 1, we're getting 1 plus 1 minus 5 minus 2. This is not 0, but this value may be necessary when sketching the graph. So let's get it. So this value is negative 5. Okay, let's see. At 1, when x is 1, we'll have negative 1 plus 1 plus 5 minus 2. This is negative 3 plus 6, which is positive 3. Let's do at 2. We'll get negative 8 plus 4 plus 10 minus 2. This is negative 10 plus 10, so this will give us 4. Okay, let's do y of negative 2. It will give us positive 8, positive 4, minus 10, minus 2, and this is 0 for sure. 8 plus 4 is 12, negative 10 minus 2 is negative 12. So we can use negative 2 in synthetic, negative 1, 1, 5, negative 2. Then you drop negative 1, that number here. Negative 2 by negative 1, we get positive 2. Add, we get 3. And then negative 6. When we add, we get negative 1. Then positive 2. When we add, we get 0. So y, a curve, is x plus 2 multiplied by negative x squared plus 3x minus 1. So again, here we know x is equal to negative 2. But for the intercepts, we have to calculate using the formula on the other one. X is equal to negative 3 plus or minus the root of 3, that is 9, root of 3 squared, 9, minus 4 multiplied by negative 1 by negative 1. So it will be minus 4 over 2, giving us negative 3 plus root 5 over 2, or negative 3 minus root 5 over 2. So we can have our sketch. Okay, we'll use the other space. Let's find the so these are the x-intercepts. So we have found the x-intercepts to be x is equal to negative 2, to be x is equal to negative 3 plus root 5 over 2, to be x is equal to negative 3 minus root 5 over 2. Now I want the y-intercept. The y-intercept is coming out to be 0, negative 2, but p of x is equal to negative modulus, meaning that we'll have negative 2 inside the modulus. So it will come out as 2, which is 2 makes it a negative 2. So it is still 2 because it is still negative 2 because there's a negative outside the modulus. And when you get as negative 2 in the modulus, it will remain positive and come out as a positive number, then you meet the negative which is outside. So when we sketch, you must not forget that there's a negative outside the modulus. Our intercepts have come out to be negative 2. So we have negative 2. So let's see. So negative 3 minus root 5 over 2. This number is bigger than negative 2. And then the other one, so it seems like all these numbers are negatives. So we have everything on the negative. So let me redo those. Okay. So we have the negative 3 minus root 5 over 2. Since root 5 is 2 point something, negative 3 minus 2 point something, that is negative 5 point something. Divide by 2, you get negative 2 point something. So it's less than negative 2, which is also less than negative 3 plus root 5 over 2. And then the intercept, where do you find the y-intercept? It is negative 2. So it's making sense. The intercept is negative 2. So now this means that our graph is supposed to, it will not cross the y-axis. I mean, it will not cross the x-axis on the positive side. It was supposed to be coming down like that, so that it goes up and then go down until it crosses the y-intercept, which is in the negative. But then it has a negative outside the modulus. So all the numbers will be coming out to be negative. So there will be no positive part of our graph. So these curves won't exist. They'll be reflected in the negative direction, meaning that our graph will be of this form. It will hit there, come down, make a turning point of, supposed to make it a bit nice, but it's difficult. Okay, let me try to redo it. So this is -3 minus √5 over 2. So try. There's a curve here, and there's another curve here, and then it goes down. It goes down, and it's crossing at -2. So all the parts which are supposed to be in the positive, they've been reflected down. So you can see there's nothing that is allowed to go above the x-axis because there's a modulus outside, and all numbers inside the modulus, whether negative or positive, they will come out of the modulus as positive numbers. Then they will meet a negative which is constant outside the modulus to make all the outcomes negative. And that's how we sketch such graphs. Do we have questions? Okay. So since we have no questions, we are done with polynomials. And this is 17:48. So cool down for 12 minutes. At 18 hours, we are starting by now. So don't go away. Just cool down for 12 minutes. At 18 hours, we are starting by now. So we'll be cutting and rejoin at 18.